Hello friends, welcome to H3 Vibrant Academy. In the last lecture, we have started the discussion on the equilibrium of rigid body in 3 dimensions. So in the last lecture, we have discussed about the introduction part. Okay, so let us move further. So what is this? So we have the reduction of a system of forces to a single force and a couple. Okay, so we have to reduce a system of forces to a single force and a couple. Okay, so let us, based on this, we have a theorem. So any given system of forces acting at any given points of a rigid body can be reduced to a single force acting through an arbitrary chosen point. Okay, so this keyword is important, arbitrary chosen point, and a couple whose axis passes through that point. Okay, so any given system of forces acting at any given points of a rigid body can be reduced to a single force acting at an arbitrary chosen point and a couple whose axis passes through that point. Okay, so let us draw this. So we have a rigid body like this. Okay, let us consider few points here. So we have a1, a2, a3, and let us take this as an. Okay, and we have the origin of vector as o. Let us consider o as the origin of vector. So now we have the position vector. Let us take the position vector of these points. So this is a1, this is a2, this is a3, and let us take this as an. Okay, now let us take an point ar here as a at a position vector of ar. Okay, and we have the system of forces as at point a1 we have f1, at point a2 we have f2, and point a3 we have f3, and at point an we have fn. Okay, so as we have considered a point ar, arbitrary chosen point ar, so let us consider the force here as fr. Okay, so we have the rigid body like this, and we have chosen an arbitrary point ar here, and the force here is fr, and this position vector with respect to the origin of vector as ar. Okay, so now let us apply two forces of equal magnitude at point o. This is fr, and let us apply a force fr in opposite direction. So this is minus fr. Okay, so these forces are equal, fr and minus fr, so this will make no sense. Okay, so this whole system will reduced to a force fr at o, that is origin of vector, and a couple that is this one. This fr and this minus fr will form a couple. Okay, and distance between these two forces is ar, so the couple will be ar cross f. Okay, thus the force fr acting at point ar of a rigid body is equivalent to an equal force fr at o together with a couple of moment ar cross fr. So these two forces, this one and this one, will make a couple of moment ar cross f. Okay, understood? So let us write down the statement once again. So we have, what is the interpretation of this is that all the forces f1, f2, f1 acting at the points a1, a2, an respectively of the body are equivalent to the forces f1, f2, fn. Okay, all acting at o together with respective couples of moment a1 cross f1. Okay, so for f2 we have a2 cross f2, similarly an cross fn. Okay, clear? So if r is the resultant of the n concurrent forces at O, and G is the moment of resultant couple of the n couples, then we have R is equal to F1 plus F2 plus Fn. This is equal to summation R is equal to 1 to n f of R. This is R. And G is equal to A1 cross F1 plus A2 cross F2. This will be equal to plus AN cross Fn. This is equal to summation AR cross FR. R is equal to 1 to n. So this is R and this is G. Okay. So now let us move further. So one more concept here is the concept of base point. Okay. So we have taken, this is the rigid body, and we have taken the arbitrary chosen point AR. Okay, and we have taken the reference point as O, that is origin of vector. Okay, and we have the force as FR. So what we have done, we have applied equal and opposite force at O, that is FR and minus FR. Okay, so what is the this will result into a single force FR that is acting at point O, and a couple AR cross FR, couple of moment AR cross FR. So these two forces will make a couple, and this force will so this will result into a single force FR at point O and a couple AR cross FR. Okay. So similarly, all the forces F1, F2, Fn acting at all the points, that is A1, A2, A3, An, okay, respectively of the body, are equivalent to the forces F1, F2 and Fn acting at O together with the couples of moment A1 cross F1, A1 cross F1, A2 cross F2 similarly. Okay, so this will result into a single force, that is Fr plus this couple, this moment, that is AR cross FR. Okay, so single force FR is equivalent to these two items. Okay, so this is single force that is acting at point O, and this is moment, couple of moment. Okay, so this point, that is O, this we have referred to as base point. Okay, so the question arises here is that if we change the position of base point, so whether there will changes, whether there will be change in value of first one is R and second one is G. The answer here is, on changing the position of the base point, there is no change in the value of resultant, rather there will be change in the value of couple of moments. Okay, so we have the resultant at R is equal to FR, R is equal to FR, R is equal to 1 to N, and G is equal to summation AR cross FR, R is equal to 1 to N. So this will change on the change in base point, but resultant will not change. Okay, so G will change on the change in position of base point, but resultant will not change because there is no change in the forces. But the couple of moment will change because on changing the base point, there will change in the value of position vector AR. Okay, as simple as that. Okay. Okay, so let us discuss further. So we have, what we have to show here is that, what we have to remember here is that, note, okay, pehla, okay, the resultant R, that is R is equal to F1 plus F2 plus Fn is equal to summation R is equal to 1 to N Fr. Okay, do not depend on choice of point O. Okay, that is base point. If you change the base point, there will not be any change in the resultant R, as simple as that. Base point on choice of point O, that is base point, because R is simply the vector sum of forces F1, F2, F1, and has no connection with position of base point. Okay, second point, couple of moment, that is G is equal to summation AR cross FR. R is equal to 1 to N. It is dependent on this. AR, that is position vector, is dependent on this position of base point. Okay. However, couple of moment depends on the position of base point. Okay, so we have, on changing the base point, R is equal to R dash, first one. Second one, G is not equal to G dash. G dash is the couple of moment after changing the base point from O to O dash. Okay, suppose this, we are point arbitrary chosen point AR. Okay, and this is the point base point. Okay, and the position vector is AR. Suppose we have changed the base point to O dash. Okay, and suppose this is the new position vector, that is BR vector, and let us consider this as a constant vector C. Okay, so since we have changed the base point from O to O dash, so the new position vector G dash, sorry, new couple of moment, that is G dash, is equal to G minus C cross R. This we have to prove. So let us show this. Okay, so we have, let us consider the arbitrary chosen point as AR. Okay, and we have the base point as O, and this is our position vector AR. Okay, this is base point, and we have changed the base point to O dash. This is O dash. So new position vector is BR, and let us take this OO dash as a constant vector C dash. Okay, so from the triangle law of forces, we have BR is equal to OAR vector minus OO dash. This is equal to AR minus C vector. This is BR. Okay, so initially G is equal to AR cross FR. Let us consider the force at AR is FR. So initially G, that is couple of moment, okay, with respect to the base point O, is AR cross FR. Okay, so now after changing the base point to O dash, we have G dash is equal to BR vector cross FR, and we have BR is AR minus C. So G dash is equal to AR vector minus C vector cross FR. So this is equal to AR vector cross FR minus C cross FR. Okay, sorry, this is summation R is equal to 1 to N. This is summation R is equal to 1 to N. Okay, and we have summation R is equal to 1 to N. This is summation R is equal to 1 to N. Okay, this is also summation R is equal to 1 to N. So G dash is equal to this AR cross FR. This is nothing but G. Let us take this as equation 1. So this is G minus, this is C cross. C is a constant vector. Let us take it out. So C cross summation R is equal to 1 to N FR, and this is nothing but resultant R. Okay, so we have taken the resultant R as equal to F1 plus F2 plus Fn. So this is equal to summation R is equal to 1 to N FR. Okay, so G dash, so we have, from here we have G dash is equal to G minus C cross R. Okay, so on changing the base point, there is no change in the resultant, rather there is change in the couple of moment, that is G changes to G dash, and R, there is no change in the value of R on changing the base point. Okay, so we will discuss further in next particular lecture. Thank you.